Ladies and gentlemen, I am honored to deliver this opening speech to the delegates of the 11th International Conference on Shot Peening. I am sorry that because of my other obligations in Paris, I could not come to the conference. So I was pleased when the International Scientific Committee asked me to deliver a small memorandum on how, back in the 70s, we started to do technology transfer in the field of shot peening and how we came to the settlement of the International Scientific Committee in Las Vegas, leading to ICSP-11 conference in 1981 in Paris. I know that during the next few days, you will listen much about loading conditions, surface roughness, peening parameters, as well as fatigue and stress of materials and components. These may initiate and propagate some cracks in you. I can imagine you already are subjected to internal stress that will be relaxed during the dinner and other social events proposed by Jack Champagne, whom I would like to thank for his excellent chairmanship. For my part, I will try to contribute to the stress relaxation in bringing some of my souvenirs when I started to put together the International Scientific Committee on Shot Peening, by traveling in different countries in order to evaluate the level of the shot peening research and technology and select ICSP members. At that time, only large companies in automobile and aircraft industry used shot peening as a design parameter. As part of my doctoral work in 1974 at CETIM, this is French Technical Center for Mechanical Industry, I started to examine past works carried out in Germany, UK, and US by pioneers such as O.G. Allman, Jack Plaster, Henry Fuchs, Horowitz, Machrauch, Peiter, and so on. My close contact with French industrial users such as Airbus, Turbomeca, automobile industry, as well as with service and equipment providers such as Sisson-Lehmann, Villabrator, Metal Improvement, Vacublast, etc., enabled me to see the tremendous advantages the industry could get from this technique, which is cost-effective and efficient. After having organized a few national conferences on shot peening in France, I realized that despite the importance of this technology, there was no international cooperation in this field. The real reason was that most of people could not distinguish between the clean shot peening and the dirty blast cleaning. Another reason for lack of international cooperation was that some commercial companies, which with much experience, were not willing to publish their know-how. The slogan was, "The only thing you need to know is that the parts go into the machine and come out with a higher fatigue life." Later on, best slogan was from Jack Champagne. "The only thing you need to know about shot peening is our phone number." My main task was to bring these companies and the scientists as well as end users together so that technology transfer could take place. I started with the USA, and fortunately Professor Henry Fuchs was the first to accept my invitation to join the committee. Henry was professor of mechanical engineering at Stanford University and one of the few who actually had contact with Allman at General Motors. In 1945, he left General Motors and started a famous shot peening company which still exists. It was an honor to me when he dedicated to my attention his famous book, Metal Fatigue in Engineering. Henry Fuchs died about 20 years ago. Our first solid industrial allies in the USA were Jerry Nachman, the president of Metal Improvement Company, Gary Balkar, Vice President of Potter's Industry, Gary Borman, Head of Materials Departments of FMC, this is Federal Mockwell Corporation, Paul Prevey of Lambda Research, and Mike Mead of VacuBlast. The visit of large aircraft and automobile industries such as General Electric, Ford, Toyota, Airbus, Lufthansa, Messerschmitt, Rolls-Royce, Renault, etc., allowed me to realize the tremendous gap which existed between these two industrial sectors. While General Electric, Boeing, and Airbus used shot peening as a design parameter, the doctrine of Ford engineers was to over-design parts, such as springs, and use shot peening as an additional security factor. I also was very much surprised that no nationwide fundamental research program in this field were carried out in the USA, while in France and in other parts of Europe, as well as in Japan and China, large research programs were underway. In the UK, shot peening were extensively used in Rolls-Royce and Westland helicopters under mainly American military standards. I was pleased that Jack Plaster accepted to become a member of the committee. In 1947, he joined Metallizing Limited and was largely the inspiration in automating the metal spraying process. He then joined the board of Tilgman Limited, later Tilgman Villabrator Limited. He is the author of the books Blast Cleaning and Allied Processes, which is still the base of the design of most shot peening and blast cleaning equipments. Jack Plaster died in 1993. Other members from UK were Dr. Al-Hassani, University of Manchester, and Professor David Kirk, who was professor at the Coventry Polytechnic. He became later the chairman of the International Scientific Committee and organized the 5th ICSP in Oxford. He is still a senior contributor of Shot Peener Journal, edited by Jack Champagne. 30 years ago, China was not an open society like today. In order to visit companies, the agreement of ministers were needed. That was organized by Professor H.C. Zhu and Dr. He Jiawen from Xi'an University, where I could see the interesting work carried out on the effect of shot peening on the fatigue of spring steels. The interesting thing was that despite a lack of information highway, Chinese researchers were very well aware of the research and development in the West. Shot peening was, for example, largely used by Dr. Wang Renji in the Institute for Aeronautical Materials. I also had opportunity to see the state-of-the-art in Shanghai Machine Tool Factory and in the second automobile works near Wuhan. I was surprised to see the high level of research carried out for the X-ray measurement of residual stresses induced by shot peening. I also saw the long way Chinese industry had to go for improving the actual application of shot peening in the factory. For example, the steel wires were cut directly alongside of shot peening machine and added to the circuit for peening of helical springs, without pre-rounding or controlling the peening conditions. They still could double the fatigue life. But you can imagine we had some hard talks there. The situation has improved after a large delegation from China conducted by Dr. Wang Renji came to ICSP-11 in Paris, and large research programs on shot peening were launched in China. including the joint research program I carried out with Xi'an University on stress-pinned torsion bars. We all benefited from those results during the past 10 conferences. My visit to Japan allowed to realize that the Japanese research on shot peening was much in advance compared with the United States and even Europe. Large research programs were already on the way, both in the industry and research centers. Professor Hirose, who was at that time the chairman of the shot peening group of the Japanese Spring Research Society, carried out a large study to correlate almond arc height and fatigue strengths. Dr. Koichi Koibuchi, head of Mechanical Engineering Research Lab of Hitachi, was involved in a research program for analyzing the effect of tensile stresses in the subsurface of high-strength steels. Professor Iida of Meiji University was, among others, involved in the characterization of peening conditions such as the shot velocity and its influence. The direct involvement of the Japanese automobile industry in these research programs enabled them to understand the phenomenon and to use the shot peening as a design factor. This was quite different from what we saw in the United States. The result was that Toyota or Mitsubishi Heavy Industries could manufacture efficient but small engines. Later on, US manufacturers signed agreement with Japanese manufacturers for making small cars in the USA under the Japanese license. It is very well known that Germans are well organized. In material science and engineering, Germany had already the DGM, this is Deutsche Gesellschaft für Metallkunde, where university and industry come together. So it was quite easy for me to find out the state of the research in Germany. I realized that a lot of fundamental and applied research on shot peening was on the way, mainly on X-ray residual stress measurement and effect of stress relaxation on fatigue behavior. Research on shot peening were mainly carried out at the University of Karlsruhe under Professor Machrauch, who accepted to become the member of the International Scientific Committee. Other member who was with us from the beginning in Las Vegas was Professor Helmut Wohlfahrt from the University of Kassel. Dr. Wolfstieg, an expert in X-ray analysis, became a member later. I cannot name all Germans who were with us from the beginning. Our relation went beyond shot peening, leading to the Pergamon publication in Oxford under my editorship of the international book series Advances in Surface Treatments and the International Guidebook on Residual Stresses, where, among others, high-level German experts were involved. The first joint meeting of the International Scientific Committee and the Industrial Observers were organized on 29 February 1980 in Las Vegas, USA, with participation of a large number of members and industrial observers. We decided to follow the advice of Henry Fuchs and gave different attributes to industrial observers and scientific members. We also decided to organize the first conference in Paris. The result went beyond our expectation. Nearly 400 delegates from 36 countries, including ministers from France, UK, and USA, attended the conference. Because of the large number of good papers, we decided that not authors, but session chairmen summarized the papers and panel of authors answered questions. Simultaneous translation in 3 languages was provided. After the conference, national organizations on shot peening were created in France, UK, Germany, Japan, and India, which continued to promote shot peening research and application and organized national seminars on the subject. Ladies and gentlemen, I am proud that 31 years later, we are still together. I think for future conferences, like what have been done for ICSP-11, we should continue to follow Henry Fuchs's advice and give the International Scientific Committee a strong role of scientific work and paper selection. I wish you a relaxed and fruitful conference, and I thank again our chairman, Jack Champagne, for making this conference a successful one. Thank you very much for your attention.